Imagine you're tasked with building a massive, towering skyscraper, right? Are you going to just show up on a dirt lot on day one, grab a pile of steel beams, and start randomly welding them together? Absolutely not. You'd need a blueprint. So, why on earth do so many of us try to build complex software without one? Welcome to today's Explainer, where we're going to demystify the ultimate blueprint for software development. Building software with vague, kind of hand-wavy requirements is just a recipe for absolute chaos. It leads to wasted time, incredibly frustrated developers, and ultimately broken systems that just don't do what the users actually need them to do. If you've ever been stuck on a dev team at 2 a.m. on a Friday trying to fix a misunderstanding, you know exactly what kind of chaos I'm talking about. To avoid that mess, we need a way to clearly define exactly what the software needs to achieve, way before anyone even sits down at a keyboard. We need a visual language to organize all that chaos. So let's talk about the Software Development Lifecycle, or SDLC. Think about where the initial magic actually happens. We kick things off with requirement gathering and analysis, and then we move right into design. And that is exactly where software modeling lives. It happens super early in the cycle, well before we hit that bottom stage of implementation and coding. We aren't laying any digital bricks just yet. We're purely architecting the structure. To put a formal definition on it, software modeling is simply the representation of the software system before coding. And because we build modern software based on object-oriented concepts, we rely heavily on a very specific visual language for this. It's called UML, or Unified Modeling Language. UML gives us the standardized shapes and lines we absolutely need to communicate really complex ideas visually. All right, so here's our roadmap for today. First, the blueprint before coding. Second, meet the use case diagram. Third, finding actors and actions. Fourth, includes versus extends. And finally, building a practical diagram. Let's get into it. Section 1. The blueprint before coding, setting the stage. How exactly do we take a massive, totally overwhelming list of software requirements and actually make it manageable? Well, the secret is essentially the oldest strategy in the book, divide and conquer. The core idea here is to divide the requirements into use cases, and then you can design and implement each use case individually. By breaking a massive system down into these little bite-sized pieces, these use cases, developers can tackle incredibly complex systems one manageable piece at a time. It ensures nothing slips through the cracks. Moving on to Section 2, meet the use case diagram, the ultimate solution. Okay, we know we need to divide requirements up, but what does that actually look like in practice?
Think about the anatomy of a building management system. You've got a few key pieces. First, you have the actors. These are the external folks, like a supervisor or a visitor. Second, you have the use cases themselves, the actions, like initiate fire alarm. Third, you've got the relations, the lines connecting everything. And finally, encapsulating all of this is the system boundary. It's literally a box that visually separates what is inside the software from who is outside using it. It's a really clean way to view the whole shebang.
Section 3, finding actors and actions, the building blocks. Now that we have the big picture in mind, let's break down those individual components, and we'll start with the who. So, what exactly is an actor? In UML, an actor is anything that interacts directly with the system. But here's the crucial part. Actors are always external to the system itself. They sit entirely outside that boundary box we just talked about. Also, keep in mind that an actor specifies a role that someone or something adopts. It's not a specific person, like, say, John Smith. It's the role they're playing at that moment. They might be a customer, a dispatcher, or, hey, even another computer system entirely. Okay, so what about the actions? What are use cases? Well, a use case is a named capability of a system. It basically describes a complete course of events that returns a visible result back to the actor. Think of it as a specific reason the user interacts with the system in the first place. Notice that a use case doesn't reveal anything about the internal coding or the structure of the system. It just says what the system needs to do, like clear fire alarm. It totally ignores how it's actually going to pull that off behind the scenes. When systems analysts sit down to actually identify these use cases, they kind of act like detectives. They look at the actors and they ask questions. What functions will this specific actor want from the system? Does the system need to store or retrieve information for them? What happens when the system changes state, like starting up or shutting down? Are there external events that trigger actions? This line of questioning connects the external user's needs directly to the software's internal capabilities. When you put all those pieces together, you get something like a multi-actor mail order system. Imagine a customer actor who wants to place an order, cancel an order, or check order status. Then, on the other side of things, we have a dispatcher and a shipping company. The specific use case of ship product actually involves both the dispatcher, who triggers it, and the shipping company, who receives information from it. It ends up being a perfect visual map of exactly who does what. All right, Section 4 includes versus extends, the tricky relationships. Now, this is, without a doubt, the most common stumbling block for beginners. Figuring out how different use cases interact with one another inside that system boundary can get a little dicey. Let's contrast these two relationship types really clearly. First, we have the extends relationship. You use extends to model exceptional or very seldom invoked cases. It's an alternative flow. For instance, if a machine is out of order or a transaction times out. Then we have the includes relationship. You use includes when you have common, absolutely mandatory functionality that's needed in more than one use case. It's factored out into its own thing so you don't have to design it twice. So the crucial point here is the arrows. And this is a surprising little fact that trips up even junior business analysts. The arrows for these relationships point in opposite, somewhat counterintuitive directions. An extends arrow points back to the base use case it's interrupting, but an includes arrow points away from the base use case, pointing directly toward the shared functionality. Memorize that convention, and reading these diagrams is going to become second nature to you. Section 5. Building a practical diagram. Putting it all together. Let's shift gears from theory to practice and map out a real-world scenario from scratch, just to see how an analyst handles a messy, real-world prompt. So, imagine our raw material is the ABC rental processing system for a video store. If you were to read through the prompt for this, you'd see a flood of details. Customers selecting videos, handing over phone numbers to a clerk, the clerk looking up the customer, entering new info, logging transactions, computing returns, a vendor entering new video info, an accountant getting an end-of-day summary. Honestly, it's a massive wall of dense, overwhelming information. So let's organize it. Here's our mental process to extract the data we need. Step 1. Find the actors. Who is interacting with the system? Well, from that description, we have the clerk, the video vendor, and the accountant. Step 2. Find the use cases. What are they actually doing? They process rentals, process returns, look up customers, maintain video info, and get reports. Step 3. Map the relationships. Where do we need those tricky includes or extends arrows? Let's figure it out. When you build that out visually, it takes all those dense paragraphs and turns them into a super clear, instant blueprint. You've got your ABC rental boundary box. Your clerk is linked to process rental and process returns. Your video vendor is linked to maintain video information, and your accountant simply links over to get EOD report. Suddenly, the whole system is just instantly readable. And to really reinforce those tricky arrows, think about the specific relationships in that rental scenario. Every single time a rental or return is processed, the clerk must look up the customer. Because it's common, mandatory functionality, process rental includes lookup customer, so the arrow points directly toward that inclusion. But entering a new customer? That's exceptional. It only happens sometimes. Therefore, process new customer extends process rental, and the arrow points back to the base case. It maps the logic perfectly. Which brings us to our final thought. If you can clearly visualize every single actor and interaction before writing even a single line of code, how many thousands of hours and dollars are you going to save? Using a use case diagram ensures you aren't just building software, you're building exactly the skyscraper the client actually asked for. Thanks for joining me on this explainer. Now go build a better blueprint